Everything that you see on the outside is compact bone. So compact bone is the dense outer layer of every bone that appears smooth and solid. Spongy bone is made up of these little things, these units called trabeculae that make it kind of look like a honeycomb of small pieces. It looks spongy, that's why it gets the name spongy bone. It's found deep to compact bone. And what spongy bone does is it lightens the weight of the bone without compromising any strength. So as we'll look in when we zoom in, the open spaces between these trabeculae in the ends of our long bones are filled with red marrow. In kids, it's all red marrow. In adults, in our medullary cavities, it gets replaced with yellow marrow. So just kind of be aware of that. Spongy bone has marrow in it, either red or yellow marrow, and then compact bone is what's giving our bone strength. So this is showing you at the gross level with our eyeballs, we can see this. I can see compact bone on the outside, and we'll look at some real bones, and you'll see that as it wears off the ends of it, you can see spongy bone on the inside. So as far as the gross anatomy of bones go, our long bone is going to form our general kind of idea about what a bone looks like. The structure of short, irregular, and flat bones are all complicated and weird, so we're not going to worry about drawing them or anything like that. Just be aware that for all of these bones, what we find is they've got thin layers of compact bone superficial to spongy bone. So the compact bone is sandwiched between connective tissue membranes. Just be aware of that. I kind of mentioned this when we talked about perichondrium. Periosteum is what we find on the outside of compact bone. Endosteum is what lines the inside of our compact bone. And then within that, we'll have spongy bone. And bone marrow will be scattered throughout it. Hyaline cartilage covers the area of the bone. That's any part of a movable joint because it's articular cartilage. So this is literally what that's talking about. Flat bones and regular bones. Short bones have an outer layer of compact bone surrounded in periosteum. And then this would be our inner layer of compact bone. There's periosteum on the outside of both of those layers. On the inside here would be endosteum. And then in here's our spongy bone. So does that make sense? The membranes on the inside are endosteum, the membranes on the outside are periosteum, spongy bone between. That's the general structure, growth structure of our of our flat bones, our short bones, and irregular bones. So we do need to worry about the gross anatomical structures of a long bone, and we're going to draw a long bone and know what all these parts are. So all long bones have a long shaft that we call a diaphysis. So this is the diaphysis. Is the shaft. And in here we have a cavity called the medullary cavity. The medullary cavity contains our red or yellow marrow. So in kids, it's red marrow. In adults, it gets overtaken by fatty yellow marrow. So sometimes you see it called the marrow cavity, medullary cavity. In here we'll also have our blood vessels and nerves and lymphatics that serve the bone are going to be running in it. So we'll say it contains vessels, lymphatics, and nerves that serve the bone. What does this mean? This is a living organ. Bones are the major organ of the skeletal system. So that's running up in the medullary cavity. The next region that we can see on our long bones are what we call epiphyses. And there's a proximal and a distal epiphysis. So one is an epiphysis, where we have a proximal and a distal epiphyses. And these are full of spongy bone and red marrow. So proximal epiphyses of our like femur and humerus. So we'll say this contains spongy bone and red marrow.
Even in adults?
The red marrow in adults is in the proximal epiphyses of your humerus and femurs. In adults, the rest of our red marrow is in our flat bones. So contains spongy bone and red marrow. So for red marrow, we'll put in the proximal for adults, primarily of your femur and humerus. And then the region between the epiphysis and the diaphysis is actually, if we're using the epiphysis part, it's a metaphysis. This has different names depending on whether you're an adult or a child. In an adult, it's what we call the epiphyseal line. And in kids, it's the epiphyseal plate, which you might have heard of as the growth plate. So if you've ever heard, oh, my kid broke their growth plate, what they did is broke this area of growing cartilage that's being overtaken by bone. And in adults, it gets completely ossified. It's completely overtaken by bone and becomes what we call the epiphyseal line. So in kids, it's the site of growth. We call it the epiphyseal plate. In adults, it's the epiphyseal line. And you can kind of see that here. Between the diaphysis and the epiphysis is the epiphyseal line. It's the remnant of the epiphyseal plate where bone growth occurs. So if we look here, we can see these things that we've drawn. Here's our diaphysis. Here's the proximal and distal epiphysis. What I didn't necessarily say is that all of these blood vessels and things are coming in through what we call a nutrient foramen. So a foramen is a hole in a bone, and our nutrient foramens are going to bring in the blood vessels that are serving that bone. Other things to be aware of. Well, this is the end of our long bones. Our long bones are all in joints, so they're covered in articular cartilage. So on the ends of the long bones, we would have articular cartilage. What type of cartilage is that? Hyaline. It is hyaline cartilage. So it's articular by name because it's found in an articulation. It's hyaline by specific type. So we would see our articular cartilage there. Other things to be aware of. Out here, we have our Peri Osseo. In here, we have our endosteum. So that if we look on the superficial layers, all of this is compact bone. Our epiphyses are full of spongy bone. Our diaphysis has a little layer, an incomplete layer of spongy bone kind of here. And then it's a hollow medullary cavity. Hollow. It's not hollow. It's full of yellow marrow or red marrow in kids. That's kind of what we got to worry about there. As you can see, this is showing out, we're taking out just a chunk from the proximal epiphysis here. And we've got, whoa, compact bone and spongy bone. The periosteum's on the outside, endosteum lines the inside, and then there's our spongy bone. You can see blood vessels branching through here. That would be full of red marrow as well. Okay, so Peri Osseo is the white double-layered membrane that covers the external surfaces except in joints. The fibrous layer is dense regular connective tissue. So fibrous layer because it's got fibrous connective tissue. And then we've got this inner osteogenic layer that has these osteogenic stem cells that give rise to most or all of our bone cells. Let me make sure I'm not skipping anything. Not yet. Okay. So our fibrous layer has our dense regular connective tissue. That's really what's going to give us a nice structure here. You can see these perforating fibers are coming in here, and then what's contacting the bone tissue is what we call this osteogenic layer. And so our osteogenic layer, we'll say, contains bone stem cells, which would be one step differentiated from our mesenchymal stem cells, right? Bone's a connective tissue. All of our connective tissues start from mesenchymal stem cells. So now if we differentiate down the bone path, then I can become an osteogenic stem cell that gives rise to most all of my other bone cells. So other things to be aware of: contains many nerve fibers and blood vessels that continue through our nutrient foramen openings. These are anchoring points for tendons and ligaments. The endosteum is an incomplete cellular layer. So that's all you need to worry about. The endosteum is an incomplete cellular layer. What kind of cells? Bone cells. It's a bone. So that's kind of what we can see with our eyeballs. So hematopoietic tissue in bones is where we have our hematopoiesis, or the formation of our blood cells, occurring. So if you look in the epiphyses of our spongy bone, so all of our hematopoietic tissue is found in spongy bone. So spongy bone contains red bone marrow. Red bone marrow has blood cells, stem cells, hematopoietic stem cells that can become any blood cell type. So when you get a bone marrow transplant, this is the marrow that's getting transplanted. And so our red bone marrow, we'll say, contains our blood stem cells, so this is the site of hematopoiesis. Hematopoiesis. That was on our list of functions. Hematopoiesis is the formation of our blood cells, and that's occurring in spongy bone. So where do we find, or in red marrow specifically? So let's talk about the places that we would find hematopoietic tissue. In kids, we find it all throughout their bones, in their medullary cavities and in the epiphyses. So in kids, it fills the medullary cavities. And we find it in our other spongy bone. Well, where did we say we have spongy bone? It's deep to compact bone in all of our short bones, flat bones, and irregular bones. So we find it all over there and in their medullary cavities. As adults, we really only find it in the proximal epiphyses of our longest, our biggest long bones, and then all of our flat bones. So our ribs and our skull are going to be the primary site of hematopoiesis for adults. So in adults, we could say in the proximal epiphyses of the humerus and femur, but then also in our ribs, skull, sternum. That's going to be our primary site for hematopoiesis as adults. Okay. Questions on gross anatomy so far? Yeah.
So if a kid needs a bone marrow transplant and they have red marrow, well, is there a specific spot they could take it from an adult to give it to them, or is it okay?
They'll take it from from adults. They take it from your vertebrae, from the bodies of your vertebrae.
Because it's specifically still red there.
Because it's in adults, it's where we have, I guess the other thing I could say is it's just where we have spongy bone. So, because that's where we find red marrow. So the other place that we have spongy bone would be the bodies of our vertebra. Now, if we think about these other bones, would it's not very easy, it wouldn't be easy, and you couldn't get a lot of bone marrow from my skull bones. I probably also don't want to be pulling red bone marrow out of my ribs. I mean, why? They keep you awake during that.
Yeah.
So, well, I mean, probably because it's in your spine, or near your spine. I'm trying to think, could they knock you out and get it from your ribs? Because I was trying to think about why, like, if you went under general anesthetic maybe, but I mean, then you're going through a whole lot of risk and things. It's probably easier to get it from your back just because then you're not looking and you're awake. And yeah. What else? We would also have it in our os coxa. So you also have it in the spongy bone that you find in your ilium. So your ilium's a big bone as well. So just kind of anywhere we have spongy bone, and there's not a lot of it. I mean, if you think about like the whole space of your skeleton, those medullary cavities are huge. So kids have a lot of capacity for producing red blood cells, and it kind of decreases with, or all blood cells, decreases with age. Okay, so as far as other gross anatomy goes, bone markings are going to be things that you have to identify on your bones. So these are the sites of our muscle, ligament, and tendon attachment. They help form joints, whatever.